The difference quotient is defined to be the quantity that we obtain by plugging x plus h into a function, then subtracting the original function and dividing that entire quantity by the variable h. In this example, we're being asked to find the difference quotient for the function f at x is equal to 4x minus 1. The first thing that we need to do is to find the function f evaluated at x plus h. So for our function f, if we were to plug x plus h into the independent variable spot, that means that we would open up a hole for that x variable, and then whatever is indicated inside here is going to be what we plug into that independent variable spot. So this is f with just x plugged into the independent variable spot, and this is f with x plus h plugged into the independent variable spot. There's not much really we can do to simplify this. We can distribute the 4 into the parentheses. It doesn't give us a much simpler expression, but it is what we're going to prefer to have when we're evaluating the difference quotient. So now we have the function evaluated at x plus h. We were given initially the function evaluated at x. So we'll put these quantities together in order to determine the value of the difference quotient. So we'll say the difference quotient is going to be equal to, we'll have a big fraction here, and in the top of the fraction, the first thing that we're going to have is f evaluated at x plus h. Well, that's what we just came up with here, and so that's what we're going to put in the f evaluated at x plus h position in the difference quotient. And then from that, we're going to subtract the original function f at x. So we'll subtract whatever that original function was. So looking back up into the given information, the original function was 4x minus 1. So 4x minus 1 is what's being subtracted here in the numerator. So we have f at x plus h, we've subtracted f at x. Now we're going to write all of that over h. So h is in the denominator of the fraction. Now essentially that's it, except for the fact that we just need to simplify. So let's anchor the left-hand side with what it is that we're finding, the difference quotient here. Again, let's start the simplification process by distributing the negative into the parentheses. So our numerator is going to be 4x plus 4h minus 1 minus 4x plus 1, and everything is still written all over h. Now we can see that some things cancel out. We've got a 4x and a minus 4x. We've got a positive 1 and a negative 1. So in the top of our fraction, the only thing that remains is 4h, and in the bottom of the fraction, we still have h. Now that we have only multiply in the numerator, we can actually cancel these h's over multiply, and this all then reduces down to just being the quantity 4. So 4 is the value of the difference quotient for the function f at x. Let's do this again for part B. First, we'll copy down the formula for the difference quotient, as this is something that does need to be memorized. The difference quotient is g evaluated at x plus h minus g of x, and we're using g this time because our function is a g function. And then when we subtract those two things, we're then going to divide that by the variable h. So to evaluate the difference quotient, the first thing that we need to find is g evaluated at x plus h, which means that we go to the g function and we open up holes for that independent variable, which is x squared, and then we still have the plus 9. So whatever is inside this independent variable spot in the functional notation is what we plug in for the independent variable in the function. So we'll want to try to simplify this as much as possible, and really the only thing that we can do is to FOIL out this quantity. Remember, you cannot distribute a square over add or subtract, so we would be FOILing this, which means that we would be multiplying x plus h times itself, and the first multiplication is x squared, the outer is xh, the inner is also xh, and the last is h squared. So when we square a binomial, what we get is square the first, twice the product, and then square the second. So that's what we have here, square the first plus twice the product plus square the second, and then we still have our plus 9. So now that we have our g of x plus h, it's time to put that into the difference quotient calculation. So g at x plus h is this quantity. So we start by putting x squared plus 2xh plus h squared plus 9 into the g of x plus h position of the difference quotient. Then from that, we're going to subtract the original function g of x. So we subtract the original g of x function, which was x squared plus 9. So that completes our numerator. Now we just write all of that over h, and then we simplify. To begin the simplify process, let's distribute this negative into the parenthesis. So the difference quotient is going to be x squared plus 2xh plus h squared plus 9 minus x squared minus 9, and all of that is written over h. Now we're going to get some cancellation. We see that the x squareds cancel out, and plus 9 and minus 9 cancel out. So all that remains in the top is 2xh plus h squared. In the denominator, I still have the h. Now remember, we cannot cancel over, add, or subtract, but we can split this numerator and give each of those terms in the numerator its own denominator of an h. So we have 2xh over h and h squared over h, and now that the operation is multiply up here, we can cancel these h's. So this first term just becomes 2x. One of the h's is going to cancel from the top with the h in the bottom, leaving just h here in the second term, which leaves us with 2x plus h as the difference quotient for our original function g of x.